In this video, we will be discussing the basic logic of sigma or summation. For sigma or summation, we will use the Greek alphabet. This alphabet is known as sigma. Now, if we have a sum of the series as 2 plus 2 square plus 2 cube plus 2 raised to 4. Now, this summation you can express with the letter that is sigma. For example, this can be written as, see, sigma 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. That is general form is 2 raised to n, where n is varying from 1 to 4. N starting from 1, ending till 4. Now, if when you get this one, you need to do this only. That is, if you are getting given something like this, that is sigma n equal to 1 to 4, 2 raised to n, if it is given. First to put n equal to 1, that is 2 raised to 1. Plus next value n will be changing to from 1, it will be changing to 2, that will be 2 square, then it will be going to 2 cube, then it will be going 2 raised to 4, last value it is finished. Now if you are provided with something like sigma n square, where n is varying from 1 to 3, then n value you will put 1, that is 1 into 1 square, you should put that value here. Then one value changing to 2, that is 2 square, one value will be changing to 3, that is 3 square. Or sigma n value varies from 1 to 3, f of x. The logic is you need to put f of n, you need to put n over here and put from start from this, that is f of 1, plus again next value will be f of 2, again next value will be f of 3. We will simply add the terms, we will increase the term, increase the value of n, and we will keep on summation. That's why sigma means summation. Now if you are provided with a series, that is series equal to s equal to 1 plus 2 plus 3 plus etc. 5. Then how many terms are there? Plus 4 plus 5. 5 times are there. So you can use sigma. Sigma means each term is calculated and it is summation. So general form is the form n itself. N is varying from 1 to 5. That is, first you will put n equal to 1, then add. When you put n equal to 2 here, add. When you put n equal to 3, add. Similarly, it will go on till 5. Again, if sigma n equal to 1 to 3, x raised to 4, then n raised to 4, n is the variable. So first you will put n equal to 1, that is 1 raised to 4, then n value is increased by 1, and since it is sigma notation, we will add the plus, that is 2 raised to 4. Now n value again increased to 3, 3 raised to 4, only till 3 we will write it. So this is how sigma or sum is used to express. Now if you are again given a series that is that is odd number, sum of odd numbers, s equal to 1 plus 3 plus 3 plus 5 plus etc., or simply 1 plus 3 plus 5, first 3 odd number. So you can say any odd number, 2n will be an even number. Before an even number there will be an odd number, after an even number there will be another odd number. For example, if you take n equal to 2, 2 into 2 is 4, 4 minus 1 3 is an odd number, and 4 plus 1 5 is an odd number. That's how the general form of an odd number. So you can write this as 1 as 2 into 1 minus 1. Next is 2 into 3, 2 into 2 minus 1, that is 3, plus 2 into 2 into 3 minus 1, that is 6 minus 1. That is, this is 6 minus 1, this is 4 minus 1, this is 2 minus 1. That's what we wrote. Here you can write this is sigma n values varies from 1 to 3, 2n minus 1 is the general form. Now if you are put n equal to 1, you will get 2 into 1 minus 1, that is the first term, that is 1, plus since it is sigma notation we will add. Again when you put n equal to 2 here, that is 2 into 2 minus 1, which is equal to 3, you will add. Again when you put n equal to 3, this will be 2 into 3 minus 1, which is equal to 6 minus 1, which is equal to 5. Again you will add. That's how sigma notation is. Now you are already familiar with the quadratic equation. What is the general form of a quadratic equation? That is ax square plus bx plus c. Here we will have a term which is independent of x, that is a constant term. That can you write it as x raised to 0? X raised to 0 is basically 1. Now instead of a, b, c, I am using different notation. That is, instead of a, I am using first constant is a, that is a0. Second constant b, I can replace with a1. That means a1, ac, instead of abc. If you are using abc, we can only have 26 constant. But if you are using a1, a2, etc., a100 is there, a200 is there, you can have infinite number of constant. So with that logic, I can slightly modify the expression of a quadratic equation in this form. That is, the power of x varies from 0 to 1 2. That is quadratic equation x raised to 0, x raised to 1, x square. That is c plus bx plus ax square. That is cx raised to 0, bx raised to 1. In that form, it's ascending from x raised to 0 to x square. Now, instead of using CBA, I am telling first constant as a0, second constant as a1, third constant is a2. Now, I am adding. So, this is the general form of a quadratic equation. Now, if I want to use sigma, then I can say each term is ai, that is a suffix I, x raised to I. See, x raised to I is varying from 0 to 2 here. That is, if you want to form a quadratic equation from this form, if you put I equal to 0, a raised to 0, x raised to 0. Now, I value increased to 1, then it will be a1, x raised to 1. Then I value is again increased to 2, that is a2, x square. Now, it is a quadratic form, one constant, this is a constant term, that is c, x raised to 0 is 1, simply it is a naught, we used to learn it as z, and here a1 is another constant bx and a2 is another constant a, simply x square. So, it is of the form ax square plus bx plus c. Now we are taking one bigger polynomial. So it has infinite number of powers. That is, power starts from, power varies from x raised to 0, x raised to 1, x square, x cube, etc., x raised to n. Now each value will have a coefficient, that is a raised to 0, a raised to 1, a raised to 2, a cube, a3, and a n. That is, these are just random constants. Then here we can use the sigma notation. I value varies from 0 to 1, ai, xi. Now again, if I use a fourth degree polynomial, this will be what? Fourth degree polynomial. Instead of a, now I am using alpha. Instead of x, instead of I am using j. That is, I can say alpha 0, x raised to 0 plus alpha 1. Alpha 1 is the number, alpha 1, x raised to 1 plus, or we can discuss with an example. Now you take a polynomial, that is a biquadratic fourth degree polynomial, that is 4x raised to 4 plus 8x cube plus 9x square plus 5x plus 6. Now I am calling this as the first constant, that is alpha 0. This is the second constant, that is alpha 1. This is the third constant, alpha 2. This is the fourth constant, alpha 3. This is the fifth constant, that is alpha 5, which means we have 5 constants here. That means alpha 0 is there, alpha 1 is there, alpha 2 is there, alpha 3 is there, alpha 4 is there. Now, with this alpha 0, the power of x is x raised to 0, plus with alpha 1, the power of x is x raised to 1, plus with alpha 2, the power of x is x square, and here it is x cube and here it is x raised to 4, which means we will have this all powers of x from 0 to 1, 0 to 4 backed by a constant. There will be always a coefficient, constant coefficient will be there. That constant coefficient, we can name it as, instead of ABC, we can say alpha 1, alpha 2, alpha 3, etc. So in general, you can use this with the sigma notation, that is sigma. These are same, these values are same. So you can say alpha coefficient is I, that is ith constant, then x raised to power I, and this value is varying from, or we can use the letter j. This is j is varying from 0 to 4. Now you can write the polynomial from this. That is, if you have this one, you can write the polynomial. When you put j equal to 0, alpha 0, x raised to 0. When you put j equal to 1, alpha 1, x raised to 1. When you put j equal to alpha 2, x square. When you put j equal to 3, alpha 3, x 3. When you put j equal to 4, alpha 4, x raised to 1, 2, 3, 4. That's how you can write it. 1, 2, 3, 4, 3, 4. This is 4. That's how you can write it. When you use a different letter instead of this one ABC, then you will get a different thing. That is, when you put this one as A plus. When you put alpha 1 as B, Bx plus. When you put alpha 2 as C, x square plus. this will be dx cube plus e x raised to 4. We used to, every time we used to use different notations, that's all. Now if I consider a polynomial that is a quadratic equation, let it be, then it is of the form ax square plus bx plus c. Now can I say cx raised to 0 because x raised to 0 is 1. Instead of a, I am using the letter notation alpha 2, and instead of b, I am using it to denote this constant as alpha 1 and another constant as c as alpha 0. That means in AP you are using a1, a2, a3. So we can name this coefficients as a1, a2, a3 or alpha 1, alpha 2, alpha 3. In that case, it will become c will be alpha 0. That means it will be alpha 0 x raised to 0 plus this will be alpha 1 x raised to 1 plus alpha 2 x raised to 2. That means simply means every term is alpha j x raised to j, where j is varying from 0 to 2. This I will notate. J alpha I means it can be a random coefficient.